hello and welcome to our webinar Lockbolts in Steel Construction. My name is Christoph Blunk. As Mark already mentioned, I have been working for Howmet Fastening Systems since 2021. And I'm pleased that you are interested in the Lockbolt technology, and I would like to tell you a little bit more about the Lockbolt technology and the use in steel structures for over the next about 45 minutes. And as Steve mentioned, if you have any questions, please drop your questions in the Q&A section, and we will try to answer your questions in the remaining 15 minutes at the end of the presentation. Or if we can't answer all questions, we will come back to you after this event. So just a few words about my career at in the fastening industry. So I obtained a diploma in industrial engineering in 2010 from the University of Rostock in Germany. Then I spent nearly 10 years in research, being first a research assistant at the University of Rostock, later at the Fraunhofer Institution, always in the field of mechanical joining technology. I also got my PhD for a design concept for shear-loaded connections with blind rivets. I later finished my career at the Fraunhofer Institution as a group leader, and then had a short engagement with a large nut and bolt distributor in Germany before joining Howmet Fastening Systems. So besides my job as a webinar lecturer, I also attend still a lot of research projects where we are involved as Howmet Fastening Systems. So our fasteners are constantly involved in different research projects. And so we always get the latest results for the use and application of alternative fasteners like blind fasteners and lockbolts. So you will also here see some current results from research. And before I go too much into detail, I just want to introduce you to the Lockbolt technology in general. And then switching to the more detailed information about how to use lockbolts in steel construction, and then closing with some examples of our projects where we have been involved in steel construction, and also how you get the most use of our fastening solutions. Lockbolts have been already used in a variety of different structures in steel construction. It can range from typical infrastructure, structures such as bridges or workshops and factory halls. Usually a big benefit comes from our Lockbolt technology if you have a lot of high dynamic loads and vibration in your structures. But these can also be used in special structures like art, as you can see on the top right-hand picture. And we are also involved in many renewable energy projects like wind industry, but also solar industry. So it's a very wide variety of applications, and we hope that we can also bring some benefit to your applications. So normally the design of steel structures, especially in civil engineering, is regulated by the Eurocode, which is valid for nearly 10 years now. So the Eurocode is a very large regulated area. So it regulates all different kinds of steel applications like steel bridges, cranes, pilings, silos, tanks, and also towers and masts. And the most widely used joining methods are welding, of course, but also nuts and bolts. And most widely used bolts are non-preloaded structural bolting assemblies according to EN 15048 or EN 14399 for high-strength structural bolting assemblies, where a defined preload is applied during the tightening procedure. So these are widely used, but they don't come without any challenges. So there are certainly some benefits, for example, to use welding to join structures, but often the preparation and after work is very expensive and time consuming. You also need a qualified workforce. So there's regular re-qualification required. So all the welders need special certificates for the different welding methods. Also, you can't join coated components. So normally, before welding, you have to prepare the joint, and after welding, rework and recoat. This also comes often with additional effort in terms of transportation, if you can't do everything in-house. So a lot of parties are involved, which makes it more complicated and also expensive. During welding, there's often a lot of heat involved, and this results not quite often in distortion of the components. So there's also rework required. For large, very large structures, often the components need to be preheated or cooled down before the joining and further assembly process can continue. And of course, another big disadvantage is that only similar materials can be joined, so they must be suitable for welding. And at the end, also the requirements in terms of EHS and the infrastructure is quite complex. And as you know, currently there is, I think, over the whole of Europe, a shortage of qualified welders, and many people don't want to work in such dangerous and dirty environments anymore. So, of course, mechanical joining methods are a good alternative. A very big advantage for mechanical joining is that you can pre-assemble or pre-manufacture every component. They can apply the final coating, transport it to the location where the structure should be erected, and simply join without any rework. But with the most widely used nuts and bolts, there come also some disadvantages. One main disadvantage is applying the preload into the joint. So this is always a very complicated process. Also, it looks quite simple from an outsider, but the preload which result in a joint is influenced by different factors. One is the coefficient of friction, which can be influenced by lubrication or also surface coating. But also you need an accurate tool for applying a preload. For example, if you want to use joints in steel construction for execution class 2 or above, you need a calibrated tool. So this is also a requirement which must be met. Otherwise, you can't be certain that the torque is accurate. And but since the torque is not equivalent to the preload due to the friction under the head or the bearing areas and in the threaded area of the or in the matching threads from nut and bolt, there can be a very high scatter of preload. So basically, the preload depends also on the tightening method you choose. So if you use, like you seen in the picture, hand wrench, It's less accurate compared to calibrated hydraulic drive. And so there are many influencing factors which cannot be always assured that these stay constant during the installation. So also besides the surface condition of the fastener itself and the components, there are also some environmental conditions. So for example, if you have installation somewhere in the field and the fasteners get dirty or it starts to rain during installation, the coefficient of friction can significantly change and result in either a too low preload, which will not guarantee sufficient preload for the design. So if you assume the full preload, for example, if you have a slip resistant connection and only half of the preload is applied during the change of the friction coefficient, the structure could fail before reaching the estimated service life. So, but also if the friction coefficient is decreased during the moisture, for example, it can also result in overstressing the bolt even during the installation. So this could also result in a premature failure of the structure. So summarizing these information, you can say that the coefficient of friction is usually hard to adjust, resulting in a high scatter of preload, while if you compare our Lockbolts to these thread fasteners, we are not affected by friction because the installation procedure is volume controlled. The main influence of the preload is based on the geometry and material properties of our fasteners. And these can be easily controlled during manufacturing and also do not change during installation. Why these change during installation will we see just in a few seconds. But before, I still want to introduce you to the Lockbolt technology in general. And Lockbolt is a two-piece fastener made of usually hardened metal and also consisting of a pin and a collar. So depending on the type of lockbolts, we have sometimes lockbolts with flanges and flange collar. Sometimes there are lockbolts with pin brake and without pin brake. But in this presentation, I will focus mainly on the bobtail lockbolt, which is the newest development in lockbolt technology, which comes without any pin brake, and this results in a higher and more much better corrosion protection. So you have no blank material after installation. So there needs to be no rework done on the fastener for high corrosion environments. And also the pintail, which we see here on the bottom end of the fastener, can also be used for deinstallation, disassembly of the joint. So it makes it more convenient to use. And the bobtail is available in a wide range of diameters, starting with 6.4 millimeter quarter-inch up to M36 for very heavy steel structures. The installed performance of the lockbolts is in accordance with the ISO standard 898-1. So we have also a similar strength grade on the pin. The pin consists of a medium carbon steel and can be hardened to different steel grades. And the collar, in opposite or difference a little bit more to a conventional bolt, is not in accordance with any standard, but it is matched to meet the minimum values of the pin. So you have always a system consisting of a pin and a collar. So these two must match to achieve the best results. Otherwise, it won't work. Some of the Lockbolts also have a feature like the helical lock roofs to allow for easier assembly. For example, fasteners with pin brakes, they don't have helical lock roofs, so it is always a bit more complicated and to install these for an overhead position, for example. How is a Lockbolt installed? So this makes, this is basically the biggest difference compared to conventional threaded fasteners. For a Lockbolt, we have an axial tightening procedure. So we see here that the pin tail will be the tool will be attached to the pin tail, and then an axial load is applied to the pin. The anvil of the tool drives then over the collar material and swages the collar material into the lock grooves of the pin, creating the determined preload and at the same time achieving a safe and secure joint without any risk of self-loosening. This process is usually very fast compared to conventional tightening method for nuts and bolts. For a typical size of 60 millimeter, the installation procedure normally doesn't take more than 2 seconds from hitting the button until full swaging the collar material into the bolt. To get a better impression of the installation, I also included a short video so you can see here the joining process in real life. So as you can see, the tool is placed on the pin tail of the lock bolt. Then the button is pressed to start the process, and the swaging here does not take more than 2 seconds. This was, for example, an M16 millimeter diameter lock bolt. So what makes it so different to conventional threaded bolts? I already mentioned that the preload of a threaded fastener is normally highly affected by the friction coefficient in the threaded area, but also on the bearing areas of the fastener. And we see here 2 different results from installation of HV set on the left-hand side. So here was a HV set which uses a lubricated nut with a very low scatter of the friction coefficient, and the intended preload here was 500 kilonewtons. But the diagram shows that after all installations, nearly the majority of the fasteners have preload less than the specified minimum. So despite that the a calibrated tool was used and also a lubricated nut, we see still a very high scatter of the preload. This can be due to environmental conditions, as I mentioned. The moisture has a very big effect, but also the lubrication itself can age and is highly influenced by the storage conditions. So that's why we see often a high scatter. On the right-hand side, we see some installation tests of a 60 millimeter bobtail. So the diagram shows the preload on the y-axis and the time scale on the on the x-axis, and we see that the resulting preload is a very constant value. So we see here for this example only a mean value of 116 kilonewtons and a scatter of 1.2% between these 10 tests. And this is due to the constant material properties of the collar and also of the installation procedure by swaging the material into the lock grooves. Another big advantage compared to conventional nuts and bolts is the inspection of our fasteners. So the bobtail comes with a special feature on the collar flange. These are so-called swage indicators. And if you have applied the right force during the installation to the tool, then you will see the swage indicators being deformed by the anvil of the tool. And this gives you the assurance that the full preload has been applied. We have also some fasteners which do not have swage gauges, but then we also offer an alternative solution using a so-called ring gauge. And these two methods give you the assurance that the full preload has been applied. When you look at a nut and bolt, you normally can't see which, if the torque has been applied 10% or 50% or 100%. So that is a very big bonus here for the using a Lockbolt. So the rework or installation retightening procedure can be completely is completely obsolete. If you need to document the installation procedure, we also offer the so-called shoe set system. This is a device that can monitor and record all the installation, and it can be saved to your quality system. Here we can also again see the biggest difference of a conventional thread to a Lockbolt. On the right-hand side, we see the collar swaged into the lock groove. So this leaves no room between the pin and the collar. And this assures the vibration resistance of our fasteners and also the high consistency of the preload. With a conventional nut and bolt, you see always a certain gap which allows the assembly of the nut, and this all results under high vibration loads or fatigue loads to a self-loosening of the nut and bolt in extreme cases. So by using a swaging process, this does not occur and is proven by a so-called vibration test, the Juncker test. So here we see three different curves of a Juncker test. The black line is an unsecured bolted connection, and you see after only 200 load cycles, almost 80% of the preload is already gone. Of course, you can use certain securing elements to secure a threaded fastener, but also this only works on certain applications. For example, there are restrictions regarding the material strength of the components and also the surface or coating thickness of the components. And you always will see some embedding, sometimes damaging the surface protection. And a Lockbolt does give you the highest vibration resistance. The blue curve is a conventional bobtail installed into a shear joint, and you see only very little loss of preload in the initial stages of the test. And this is due to some embedding of the collar and the pin head into the components. But after that, there's also almost no loss of preload, even after 2000 cycles. The special design of the Lockbolt in regard to the lock grooves also results in a very high fatigue resistance. So when you have a look at the conventional thread, as we have seen on the previous slide, we see that there's a very sharp notch in the thread area. And this leads to some stress concentration, resulting in a very low fatigue resistance of a threaded fastener. So just to get an impression, the fatigue resistance of a threaded fastener is usually not more than 10% of the static load capacity, mostly even less. And due to our special thread design, we have at least 3 times the fatigue resistance of a conventional threaded fastener. So this is already, this has been tested in a big test program. And here on the right-hand side, as used in the Eurocode, you see the so-called notch group. So for our bobtail lock bolts, we achieve a notch group of 71, which is 71 Newton per square millimeter of fatigue resistance compared to 50 Newtons per square millimeter at 2 million cycles for a conventional threaded HV bolt. So since despite that the difference doesn't look very significant, if you look at the plain numbers, it makes a little bit bigger impression. So for example, an increase from notch group 50 to notch group 71 means that 42% more fatigue stress can be endured per square millimeter for the same diameter basically. So this could result in using a smaller size of lockbolt or even using less fasteners in total if you switch from HV bolts or threaded fasteners to lockbolts. Here on this table, this is again highlighted depending on the actual stress in your joint or on your fastener. This can increase the fatigue life up to the factor of 9, depending on the position of your or the amount of stress you have, and with the changing slope of the fatigue curve, the fatigue resistance even increases in direct comparison to the threaded fastener. So that sounds probably very promising, but this is not just a marketing value. We have seen our fasteners resulting in very high fatigue resistance also in some research projects. Here are a few examples of failures for welded connections. So we see here, for example, cracks on the support structures or some cracks originating in the neck filled weld and at the end of the rail weld. But due to these cracks, basically the structures cannot be used anymore. And in this research project, which was conducted by the University of Applied Sciences in Munich, there was intention to investigate different repair methods for older welded structures to increase the remaining service life. So in this project, 6 different joining methods were compared against each other. First of the method was a conventional welding method, then a standard M12 HV bolt was used, also M20 HV fit bolt, a thread forming fastener, and an M12 bobtail lock bolt, and also as a last method, a structural bonded joint was tested. So on the right-hand side, we see the installation of the M12 bobtail using a battery tool, and these specimens were then loaded into a test machine. And on the right-hand side, we see the results here from these comparative tests. And in the first diagram, the blank squares, white squares, show the original or a welded structure in the original design without any damage. So it was basically newly welded. And then compared to these 5 other mentioned joining methods. So the blue triangles show the results for the lockbolt, and we see that we have seen the highest fatigue resistance with our lockbolts compared to the other joining methods. So in this case, the lockbolts and also a thread forming fastener was used for further investigations using a pre-stressed specimen which were then reinforced with this repair method. And in comparison to the damaged welded structure, there could be achieved increase of the remaining fatigue life using Lockbolts of more than 30 times of the damaged structure. So here we can see a very good result in a typical application. In Germany, for example, we have a lot of old structures where there's crane operation going on, and due to the crane operation, there's a lot of fatigue load in the welded structures. And so now we see a lot of damages after reaching a certain service life, and it would take too much time and effort to replace it by new structures. So there, and within the project, there was a very good repair solution found by using Lockbolts, and so all the structures can be repaired with the Lockbolt, reinforced Lockbolt joints, and then the service life can be still increased to a certain defined level. What is the requirement to be able to use Lockbolts in steel construction? This is always a question we see when discussing with our customers. So the civil engineering or steel construction area is a very regulated field. So typically for civil engineering structures, for example, you can only use standardized products. So either the construction product must be in accordance with a national or European harmonized standard, or you need a special approval. So for our Bobtape, for example, we have obtained national approval with the German Technical Building Authority. And within the approval, we have, during the approval process, we have done a lot of testing in terms of shear, tensile, fatigue, but also preload. And this can now be used as an alternative to the mentioned preloaded bolts. But for the rest of Europe, typically an European technical approval is required. But at the moment, we are still waiting for the publication of the assessment document in the European Journal. So hopefully this will take not too much time until this is released, and we can also transfer our technical approval to the European technical approval. But on the other hand, there's also the possibility to obtain a type approval for certain constructors or use Lockbolts as special fasteners in accordance with EN 1090-2. So here we have will support this guidance. If you have any questions how to apply Lockbolts to your constructions, please contact us. I will provide the contact details at the end of the presentation, and we are happy to help you to use Lockbolts in your structures. If you want to design the joints with Lockbolts, the national technical approval from the German Building Authority is probably a very good guidance. So this includes Bobtape diameters M12 up to M36 in grade 10.9 and covers shear and tensile connections for static and dynamic loaded constructions. There's also some design rules for eccentric loaded structures included, and all the design rules are in accordance with Eurocode 3. So this means that you can basically substitute the values for HV bolts, HR bolts, TCB bolts by the values stated in our technical approval here. And apply these to your structures and so gain access to the high mechanical performance of our fasteners. So as I mentioned, the DABT testing was included tensile tests, shear tests, fatigue tests, and also regular quality audit of our manufacturing site. So during the process, we did, as I mentioned, a lot of preload tests, also a lot of shear tests with preloaded and non-preloaded structures. Different surface preparations were investigated. So there we have also been involved in numerous research projects. So basically, if you want a slip-resistant joint, you can use the surface preparations in accordance with Eurocode 3 in the EN 1090-2. But also other alternative surface preparation methods to increase the slip load factor were also investigated in public research projects. So if you need any additional information in this regard, please contact us after the presentation, and we are willing to provide the necessary information. But not only shear connections can be used with Lockbolts, also the tensile load bearing capacity was investigated, and also the preload time behavior under tensile stress. So basically, Lockbolts can be used for any category covered by the Eurocode from category A to category E. So all the criteria which need to be fulfilled have been tested and evaluated, and all the design values are published in our national technical approval. So we also provided a little technical guideline or leaflet for the use of bobtails in steel construction. So if there's any question remaining, let us know, and we are happy to support. For other Lockbolts besides bobtail, there are also technical bulletins or guidelines for the design and use of Lockbolts. So by the EFB, the European Research Association for Sheet Networking, where I was also involved, we developed two different guidelines. One introductory guideline for Lockbolt systems, where all the properties and the general use of Lockbolts is explained, and also the second part, the design rules. So if you have intention to use another fastener than the bobtail, like a C50 Lockbolt with pin brake, and then we are also happy to assist here with the design knowledge, which is also published in these guidelines. So to find the right fastener, we have an online catalog. So here you can search for a certain part number, but also select a certain product type or diameter, material, and then you will get a direct result regarding the clamp values, the tensile resistance, shear values, but also the grip range where the fastener can be applied, and also the geometrical dimensions of the fastener, the available surface coatings for corrosion protection, and also you find the information which tool can be used for the installation and what other equipment you might need to use the fastener. If you can't find the relevant information, please don't hesitate to contact us directly, and we will support you in finding the right fastener. In general, we have different installation methods, different tools, depending on the fastener type, but also on the diameter of the fastener. So basically, hydraulic installation tooling can be used for any diameter up to the largest diameter of 36 millimeter. It has usually the fastest installation speed and uses a separate hydraulic or battery power rig. Battery tools are, of course, more flexible and easier to use, but due to the high installation load for larger diameters, use is limited to maximum of 14 millimeter bobtails. So in this case, you can, of course, use the battery tool, but if you have a high number of installations, it might be more efficient to use a hydraulic powered rig. And typically, the battery tool charge is sufficient for 300 up to 400 installations. The hydraulic tool is also a third alternative, suitable for small to medium-sized fasteners and lower volume applications. But of course, you need always an external pressurized air supply. So depending on your conditions where you want to install the fasteners, if it's in the field or somewhere in the factory, we will help you to find the right tool for you. Regarding the corrosion protection, we offer a bright variety of different coatings. So here you can see a fastener type and the matching different coatings with the resistance, corrosion resistance in hours. These are on uninstalled performance before installation. As you have seen during the presentation, the collar will be swaged during the installation process. So that's why we have some of the material properties changing during the installation, but also the surface condition of the collar changes slightly during the installation process. And that is also why we have done some field tests and lab tests with installed fasteners. So besides the general spec for our coatings, we have also results for installed corrosion performance. So for example, here you can see the results after 1,440 hours in a salt spray test for the bobtail with a zinc flake type of coating. But since the lab tests don't always resemble the real world environment, we are also involved in public research projects where we have tested free weathering tests, or have done some free weathering tests with our fasteners. So you can, on the right-hand side, you can see, for example, some results after 2 years of exposure on the island of Helgoland in the North Sea. So this was a quite strict test. Exposure in the real world sometimes is even shows better results than the harsh lab test. So if you have any special requirements regarding the corrosion resistance, we are also happy to support you with further information. Some of our coatings are already approved by the German Building Authority, but we are constantly testing our coatings and improving the performance with our suppliers. So if you have a special need there, let us know and we will provide you with the latest results. To get some impression where bobtails are used and why they are used, I have also prepared some examples from steel construction. So, for example, in Germany in 2014, a big boat lift was built, and we provided lockbolts for the rope discs. So, in total, 112 rope discs were assembled. They had a diameter of 4 meters. And due to the long service life of the structure, which is 80 years, the requirement was to have, basically a maintenance-free joint. So nobody wanted to remove or retighten or maintain these joints. So we supplied a total of 26 or nearly 27,000 fasteners, 240 per disc. And these were installed into the structure and are now in service, and hopefully will also be for the next 70 years in service without any complaints. Another application is in manufacturing halls where you see a lot of vibration due to machinery, for example, or goods handling equipment. And so the Lockbolt is a very good fit here. We have seen some customers complaining about nuts or bolts on the factory floor. So the whole production had to be stopped due to loose bolts in the structure. And so, for example, on the left-hand side, we see a factory from Audi where these bolts were installed, and all the cars are, transported, or the transportation system for the cars in the manufacturing site is attached to the steel girders, and so they had a lot of issues with self-loosening nuts and bolts, and so now they are using the Lockbolt solution, and also have applied an own patent for their structures and are very happy with the results. You can also see here in a real-life environment the installation procedure of the Lockbolt, so you get the impression how fast it is again. Sometimes it might be necessary to use a conventional nut and bolt for alignment of the structure, but then you can replace the fasteners, the thread fasteners, with a bobtail, and as you can see, the installation is done in a very fast and accurate way. I mentioned also that a lot of projects we are involved in the wind industry. So here you can see different tower designs, and these tower designs also use bobtail lockbolts due to their high fatigue performance and also to the fast and easy assembly process, installation process. And of course, due to the maintenance or no requirement for any maintenance in mechanical terms. So with increasing height and also power of the wind turbines, also the service life increases. So at the moment, the service life of a wind turbine is between 25 up to 30 years. So in such a structure, you can't send up somebody up the tower and retighten any bolts in a regular time. And so the bobtail offers here a maintenance-free, high-performance solution. This specific tower was erected more than 10 years ago, close to the North Sea. So we have also done some inspections after now 11 years. And we see the joint in a general good conditions. Only a few fasteners showed some corrosion on the pintail of the pin due to the probably not correctly applied tooling. So sometimes if the tool is not attached correctly, we see some local stress and some of the coating is damaged. But the collar and the pin itself, which are relevant for the structural integrity of the joint, are still in a very good condition. So there was within the 11 years, there was no maintenance done on the joints, no retightening necessary. So these stand there without any additional work to be done for the next probably 10 years at least. So here the cross, sorry, that has been was moved, but the tower location is here, not far from Hamburg, approximately 30 kilometers from the Baltic Sea. So we have also a maritime climate there with a salt in the air, and so based on these conditions, we see here very good results. Requirements in your joint. We also offer sometimes a stainless solution in aluminum, and probably for our listeners or attendees from the UK, they probably know this structure. This is a Kelpie's monument in Falkirk in Scotland, and each of these horse heads is 30 meters high and weighs around 300 tons. And here we provided around 12,500 stainless half-inch C50L lock bolts. And here the customer wanted a fast installation without any issues in regard to galling. For example, if you want to install a threaded fastener, you always have to use some kind of lubrication. Otherwise, the nut and the bolt will gall, and it's not possible to apply a defined preload. Also, the preload scatter is an issue because the structure is exposed to high winds and a lot of wind loads. So it's a dynamic structure, and since there were more than 12,500 fasteners used, it was impossible to maintain the joints, to retighten the joints, and check for preload. So that was also a reason to choose a Lockbolt. And also, since this was made of stainless steel, it should be tamper-proof to avoid any tampering. So in summary, Huck Lockbolts are engineered for fast, safe, and accurate installation. They do usually not require a high level of qualification for the personnel. The training takes only a general introduction, a couple of hours or in one-day training to get used to the tooling and the fasteners. And installation usually is done in under 2 seconds, and the fasteners are suitable for category A to E connections in accordance with Euro Code 3. They have unmatched static, fatigue, and vibration resistance, and maintenance-free joints can be achieved using Lockbolts. There's no need to check in a regular interval the joints or retighten the joints, and this saves valuable assembly time, but also, especially for the customers, the lifetime cost is significantly reduced. If you have further questions regarding our product portfolio, please use this slide for contacting the sales partner in your region. So if you have any questions, reach out directly to them, please. Otherwise, we also have a website where you can find additional information and also can send inquiries to our sales team in Telford, UK.